Hello, everybody. My name is Nguyen Myung, and I lead our spatial products here at Precisely. Today, I'm going to take some time to talk to you about our data graph API. Our data graph API is a cloud-native API which provides access to hundreds of different data products and integrated spatial intelligence capabilities. So Precisely works with over 12,000 organizations globally and 93 of the Fortune 100. But one thing that we're seeing is as we discuss and work with organizations and users adopting AI technologies, we're commonly hearing about the edges of AI, and in particular LLMs, of course, always trying to provide an answer or an inference. We understand these challenges to be presented to us as biases or hallucinations, but really it's rooted in the underlying lack of data, accuracy, quality, and precision in order to have the data integrity to make trusted decisions with that information. So one thing we obviously know with LLMs in particular is that there's never enough data, right? AI models require more and more data in order to evolve and in order to be trained and learn and to provide better data and more accurate results. However, therein lies the problem, right? Acquiring high quality data in large volumes and varieties of data is not simple for organizations. Identifying, vetting, testing, QAing the data, whether that's internal data or external data, and then understanding how to create and manage those data pipelines for AI models to use is incredibly time consuming. In fact, so much so that entire teams and departments have been created within the enterprise within the last decade, called data engineering teams, just to be able to handle these problems around building quality, trustworthy data pipelines to be used throughout the organization. In fact, just as a side story, when I used to run a data science organization at prior jobs, I would say 70 to 80% of my team's time went into data engineering tasks as opposed to data science tasks. So the third part of this is that context is king in data, right? So data assets are, of course, valuable. Again, reiterating, everybody is trying to get their hands on more data. However, many organizations don't realize that what's missing in your data assets is that you need to be able to have context between those data assets to one another. Or another way to say it is that there needs to be a way to connect or enrich dataset A to dataset B to dataset C in order to amplify the value that an organization can extract from the data. A really simple example of this is if I'm trying to open a coffee shop in, let's say, Austin, Texas, what information would I need? What data would I need to be able to do that confidently? Of course, you might have sales data, right? Where do people traditionally buy, or have I sold coffee before? And where have I sold those products or those coffees? Another piece of information could be foot traffic data, or daytime versus nighttime traffic data, weather-related data, competitor data, demographic data, new development areas, right? So as you layer on those different contextual layers of information, treating those data products as separate silos is not enough. You need to be able to interlink those data products together to make better decisions. So that's where the data graph API comes in, right? The data graph API provides access to hundreds of different data products with thousands of different attributes or features for your AI models to leverage. And the data graph not only allows you to leverage all of these data sets, right? They're automatically updated on monthly intervals so that you can trust that the data isn't stale, while also being able to trust that it's been vetted and assessed through our data quality checks and balances. They're also contextualized with one another, like I just mentioned. So each data set contains location or geospatial attributes. So not only does each data product have direct relationship with one another, but it can also be enriched to your own data, provided it has location context. So let's get into a demonstration of this. So here I'm showing you the Precisely API developer portal. And this is publicly available, right? You can sign up with a free trial to be able to start using our developer portal. And sorry, let me just get this screen out of my way. So just to give you an overview of our data graph playground in our dev portal. So this data graph allows you to kind of explore interactively how to query and work with the syntax of our data graph engine, which is a GraphQL based API, right? So here you can see that our structure is I'm defining a query. And in this simple example of this query, I'll just run this quickly. I am defining an address as an input, right? So there's location context here, and we are then taking that address, of course, and then providing you the locational context of that. And by querying that address, what I have access to do is query and search across all of these additional data products, right, that are trusted and vetted by Precisely. So I can query for building data, parcel data, address data, property attributes, places or POIs, even weather-related perils and risk data like flood risk or coastal risk or wildfire risks. So I can basically scan any of these data sets. And of course, these data sets have hundreds, if not thousands of different attributes available to you to be able to augment your AI models with additional context. And in this case, I queried this address in Denver, Colorado. And then by querying this address location, I'm also requesting information about the building's data set. So if I go to the buildings schema here, right, I can again scan in the data graph playground the entirety of all the attributes or features that this building's data set has, and I can define it here. And what's even more important is going back to that context is that I'm not just querying buildings. So in this case, I get the building result here in my response, but I'm also then able to nest and query places from that building. So in this case, I'm looking up an address, and that's correlating to a building, which then correlates to all the unique businesses that exist at that building, because it's, in this case, it's clearly a commercial building, right? It's a commercial building with multiple commercial storefront properties. So there's Starbucks, there's an Einstein Brothers bagel shop, and what now looks to be a Dough Deli closed business, right? So these are all definable here within the data graph. So I can get access to all of this enriched data content simply through a single API interface. And then if I want to, of course, let me find another field here. Actually, let me go to the buildings. In buildings, I might just say I want elevation, I want, and the building area, right? Building type and building area, right? So I can kind of dynamically structure my request and then the response that I get to feed my AI models. Another example of this is we can use spatial enrichment. So I'm just going to go to another tab here and just to show you this free little tool that we can use to visualize data geospatially or on a map. And let me go to the Las Vegas area. So as I zoom into Las Vegas, something that I might do is, let's use that example that I was referencing earlier, where maybe I'm interested in opening up some kind of a business. Maybe it's a coffee shop, right? And maybe I've targeted this kind of suburban area of Las Vegas. And so what I might want to do is I might want to just quickly draw a crude area around this neighborhood. Maybe I've targeted this area, this neighborhood as an interesting area that I've been exploring. Maybe I want to digitize this. And now I get to create a little boundary, a little geofence around this neighborhood and say, you know what? I want to understand a little bit more about this area. So it creates this nice little well-known text formatted geometry for me. I can copy this polygon and I can input that, which I think directly in here. And I have a query structure here that defines my input geometry. I just have an input ID in case I want to provide some kind of ID to track this request with. And I also can define the spatial function. So again, if I have questions about this, I can go all the way back to the docs, go to the query methods, identify the get by spatial, and the spatial functions will tell me all the different spatial predicates I can use to perform a spatial search or spatial enrichment against this data set. And then what I'm doing here is I'm defining the various buildings data that I want. In this case, I just want some metadata. I want a summarized level of how many unique buildings are in that area of interest that I created, how many parcels are in that area of interest. And then as I get to places or POIs, I want to know the number of unique businesses and then some more specific information or more specific attribution there. So I'll query this. And what it'll do is it'll query that area. It tells me there's 304 unique buildings, 312 unique parcels, and 40 unique places. And of course, with those places, I can go and scan through all these attributes and understand what kinds of businesses exist there. So if I'm opening a coffee shop in this area, I can see what kind of competitors might be there. I can see what kind of adjacent or complementary businesses might be there to determine whether or not it's a great location to open up my coffee shop. And if you have any other questions, please feel free to reach out, and we're happy to answer any questions either here or offline. Thank you.